Welcome to clickmyproject.com. Here we are going to discuss about a reduced complexity MIMO receiver via channel ordering. Wireless communication system with multiple transmit and receive antennas offer the significant advantages in terms of increased data rates and the reliability over those of single antenna system. So the creation of multiple input multi-output system plays a major role in communication system. With the design also consider these important factors, that is higher data rates and acceptable computational complexity. If the uniform distribution of the data symbol at the transmitter is assumed, then the maximum likelihood detector is optimum in the sense of achieving the minimum error probability. So the conventional zero forcing equalization minimum mean squared error equalizer were proposed to estimate the transmitted signal factor. While the complexity of the linear receiver is low, they experience a substantial performance loss. So here the problem of complexity and number of multiplications are carried out for a channel ordering. The brief review of SDR, semi-definite relaxational maximum likelihood detector, is formulated with the relaxation techniques, and also sphere decoding, which provides the reduction of complexity and the number of multiplication also small. So the comparative analysis of semi-definite relaxational and the sphere proposed decoding algorithm, which reduces the complexity 5 times better. So the complexity reduction and also the number of multiplication, which significantly improvises the bit error rate probability of the message signal. So the bit error rate probability curve also calculated and plotted in this window. This is the flow diagram of our proposed system, which consists of 5 major blocks: MIMO system, sphere decoding, tree traversal, semi-definite relaxational coder, comparative analysis of sphere decoding and semi-definite relaxational coder. MIMO system. It can be a representative of many types of systems, that is some of the CDMA system and frequency domain based networks. The wireless communication networks are based upon the multiple antennas for a transmitter in a transmitter side as well as the receiver side. So multiple input, multiple output system that has to be useful for time, frequency, space representation of the message signals. Then second, sphere decoding. Sphere decoding, it is the closest lattice point searching algorithm which achieves the maximum likelihood estimated. There are two stages: pre-processing, tree search. In a pre-processing stage, the identification of root node is important. The computational complexity of the sphere decoding tree search stage depends upon the efficiency of the pre-processing stage. The goal of pre-processing stage is to transform the original constraint problem into the form which is favorable to the search algorithm that we are used. Tree traversal. An efficient tree traversal is proposed to reduce the computational complexity. To minimize the unnecessary computation, the proposed algorithm visits the node at most once, as the recognition directs the algorithm to search only meaningful nodes for our communication. When the leaf is reached, backtrack algorithm also utilized to get the root node, which minimizes the complexity. Semi-definite relaxational. Semi-definite relaxation proposed for MIMO detection in communication system by employing proper QAM constellation. After solving the semi-definite relaxational problem, the SDR solution approximates the original problem. Comparative analysis. The comparative analysis of bit error rate probability after computing the reduced number of nodes and the number of multiplications that has to be made in the bit error rate probability curve. Next we are going to discuss about the running procedure of our proposed system. It consists of 5 major functions, one main function, and sub-functions are sphere decoding determination, semi-definite relaxational coder, next sibling of which corresponds to sphere decoding algorithm, and the computation of first child, which is also corresponds to the semi-sphere decoding algorithm. In our sphere decoding algorithm, the complexity reduction is the main thing. So the complexity reduction is done by using the number of nodes traveled and the number of multiplication carried out to perform the actions. The complexity, it is typically characterized by number of floating point representation, that is the function of complex additions and multiplication. So efficient tree search algorithm is used in sphere decoding process. The tree traversal approaches backtrack approach is also discussed in this subfunction. The semi-definite relaxational coder, which decodes the samples. Both sphere decoding and semi-definite relaxational coder are applied in the receiver side. So the reduction of complexity is the major thing to perform the number of nodes addition and number of nodes multiplication carried out in the communication process. The tree search procedure. Initially, the root of the node is computed. After the root computation, the siblings are calculated using this compute next sibling function, and the child of that sibling is also estimated. If the destination node or leaf node is reached, backtrack search process also utilized in this model. Finally, the number of nodes, it returns the number of nodes traveled and number of multiplication carried out as the output value to the main function. And also the bit error rate computability is achieved using this semi-definite relaxational algorithm and sphere decoding algorithm. By the proper determination, we can get the bit error rate analysis curve as required. Now I run the main file. The simulation procedure, which shows the comparative analysis of bit error rate probability with various number of signal to noise ratio decibels with SDR RBR detector and proposed sphere decoding algorithm. Here the average number of nodes visited, which is to be reduced when the signal to noise ratio is increased to some specified value. If the signal to noise ratio is keep on increasing with the value of 0 to 30, the number of nodes that should be reduced to the minimum value, and the number of multiplication, this also reduction of multiplications, which various number of signal to noise ratio is also calculated in this plot. So the number of transmitter and receiver, they are all varied to 2, 4, 6, and the modulation technique also varied for 1664 modulation technique, which shows the corresponding node travel and multiplications carried out, which is to be minimized for a certain values. The comparative analysis improvises the sphere decoding algorithm, which is adaptable to the wireless communication system. Thank you.